Welcome to Study Loop.
In this problem, you're asked to design a telescope that basically is two lenses, each with a focal length of 0.5 centimeters and 3 centimeters. These lenses are 20 centimeters apart, and it's also telling you that the image distance of the second lens is 100 centimeters to the left. The fact that it's telling you it's to the left tells you that it's going to be a virtual image. So you do need to go back and add that little negative to indicate that it is going to be to the left of the lens. And you want to know where an object should be placed so that we produce this image distance. So to do that, we're actually going to use the thin lens equation. So 1 over dO plus 1 over di equals 1 over f. And we want to solve for dO. So 1 over dO equals 1 over f minus 1 over di. And then I want to solve just for dO. So that's 1 over f minus 1 over di. Now I am talking about the second lens here first. So I'm going to go ahead and put a little 2's to clarify. And then this becomes 1 over 3 minus 1 over negative 100 to get a distance of the object as 2.91 centimeters. That tells you that my object distance of my second lens, so DO2, is 2.91 centimeters. That's also the location of where the image is for the first lens. So that means this distance here is this distance minus this distance. So that gives us 20 minus 2.91 gives us a DI2 for the first lens. I'm sorry, DI1 for the first lens as 17.04 centimeters. Okay. Now that we know our image distance for the first lens, we can use that to figure out what our object distance is. So that becomes 1 over, we can use the exact same equation actually. So 1 over, actually let's skip to that last piece. So DO1 equals 1 over F1 minus 1 over DI1. 1 over 0.5 minus DI1, which we said was 17.04, gets us a DO1 of 0.52 centimeters. And that would be for part A. For part B, it's asking for our angular magnification, assuming a near point of 25 centimeters. So for our angular magnification, it's going to be our DI1 all over times our near point divided by DO1 times DO2. Okay. And so again, instead of using DI2 for the first one, we're actually going to be using the near point of the eye since this is a microscope. So we do want to put the image where the eye can see it. So that's why we're using near point here instead of DI2. So this becomes DI1, which we calculated to be 17.04. DI1, and then this was 25 centimeters, and again, it's to the left since it's a virtual image, and then DO1, we calculated to be 0.52, and our DO2 was 2.91, so 2.91, can almost round that to 3, and you should get a negative 272.4. Again, this is a ratio, so this does not have any units.